So welcome to the course. I will be your instructor. My name is Mike Limburger, and I have been a Linux system administrator for almost 7 years now. While learning Linux, I was introduced to grep, and that's a command line program, and fell in love with regex. I started learning programming because of that love for regex. I started with PHP and then went to Perl because regex was implemented in such an amazing way in Perl. And now I'm learning Ruby. Before that, I worked in the radio industry as a commercial producer, so I'm really big into media, video editing, and that kind of stuff. I also, for fun, run a meetup.com group in the Toronto area called Techalicious, where I give free classes on various topics in technology. If you're in the Toronto area, feel free to check it out. I do a lot of regex-related stuff. I also started my own YouTube channel at youtube.com/Mike Limburger, and I'm going to post tons of wacky regex solutions to various problems. So feel free to check it out. And yeah, that's my background. As I said, I just love parsing data with regex. Every program that I make pretty much utilizes regex in some major way or form. The kind of stuff I code are things like system daemons or utility scripts that back things up, bulk correct problems in code, web scraping, things like that. If anyone out there actually wants to hire me full time to do regex all day, every day, I'm your man. Please contact me immediately. Okay, that's all I'm going to say about myself. Hopefully you will enjoy the course. Just remember, regex is pretty vast and has a lot of rules. I'm going to introduce it piece by piece. You may not see the big picture at first, but we have to start small and work our way to the magic. So there's going to be a lot of things I'm not going to cover. It was very difficult to decide what I was going to include and what I was going to omit. At a later date, if people like what I put together in this, I can add more topics. But for now, I think you will gain a pretty good foundation that will get you going. This course is designed for people with some programming experience, but when I think about it now that I've said it, it's not really necessary because regex is everywhere, even in utilities, in word processing programs, all over the place. If you have questions, feel free to post them. I will try my best to answer everything. And if there's any errors or something doesn't make sense in something I put together, let me know as well, and I will correct the mistake. All right, so with all that said, let's begin. All right, so welcome to the introduction to regular expressions. We're going to dive right in with the question, what are regular expressions? So regular expressions are used for things like pattern matching, text manipulation, and parsing data. What exactly does that mean? Here's an example on the screen. Now, I'm not going to explain exactly what I'm doing just yet. I'm just going to demonstrate the power of something you can do with regex. So I've got this list here of 3 email addresses, as you can see, and they also include the person's name. All I want is the emails. And I don't want the rest of the information. So with a regex, I can target exactly what I'm looking for. So as I said, this isn't going to be an efficient regex, but it's just an example of something you can do. So as you can see, with that hieroglyphic sorcery style syntax, I was able to target just the email addresses alone. Now I'm going to go into more details exactly what I was doing, and at the end we can do a more efficient regex to actually target email addresses. But that just gives you a little example. So regex, parsing data. Now they're available in many modern programming languages. Think of them as like a mini sub-programming language, and they exist in things like Perl, PHP, Python, Ruby, JavaScript, as well as countless other like utilities like grep, which is a software program on the command line in Unix, Linux-based systems. So regex also comes in different flavors or engines. So this is based on the programming language or the application. I'm going to be focusing more on the PCRE version. This stands for Perl Compatible Regular Expressions. Now, Perl is a really cool programming language, and they've been credited for popularizing the usage of regex. Now, PCRE is also used in PHP, for example. The languages that I know are Ruby, Perl, and PHP. So what I'm going to try to do is I am going to give a PCRE slant on when I show my examples, but I'm going to try to be as engine neutral, and so the regex syntax you learn in this tutorial can be applied everywhere, or at least I'm going to try my best to do that. Here's a link below if you want to check it out on Wikipedia, showing all the different types of regex engines out there. That's what makes it kind of tricky sometimes, because there are subtle differences all over the place. But as I said, I'll try my best to give you kind of a neutral syntax that can be used across the board as best as possible. All right, so without further ado, let's begin. All right, so just to avoid any confusion that may arise from this, you'll be hearing me refer to regular expressions as regex, and this is quite normal. This is probably what most people will be saying when they are referring to regular expressions. Just know that the two things mean exactly the same thing. And there's also a third one, regexp or regexp. I'm not sure how to pronounce the last one, but just so you know, to avoid any confusion, as I said, there are multiple ways to refer to the same thing. So by now you might have noticed I'm using a program, and this program is called Regex RX. And you can think of this as like a regex visualizer. If you're interested in purchasing this program, you can find it on the App Store, the Mac App Store, and it's about $6.99. Yeah, it's exactly $6.99. If you're on a Windows-based computer, they have a good one here at the website Regex Buddy, and it's a very I've used this one before, and it's really good, but I believe, yeah, it's $39.95, so it's a little bit more expensive. So those are two options if you wanted to follow along with your own regex visualizers. If you don't want to spend the money and you want a free option, have no fear. There is a free option. There's tons of online regex visualizer type programs. This one is really cool. I really recommend it. It's called regex101.com, and as you can see, there's different flavors or engines right here. So you can select, which is the one we'll be using primarily, is the PCRE, and they actually even put in PHP, which it's compatible with. One little trick I'm going to show you, this is going to be a little more advanced, just take note of it for later, is that as you can see, it looks like you can only do one line, right? But no, it's not true. You can do multiple lines by hitting return. The only thing is that you have to put in this inline modifier, and this just means free space mode. That means I can now do that. Pretty cool. If I didn't have that there, it won't match. I'm going to go into detail later about the different modes you can use. I just wanted to show you that you can do multi-lines, because free space mode is pretty cool because it allows you to do things like comments as well. And as you can see, the match down here, cat still matches. I just wanted to throw that out there. As I said, a little more advanced. We're going to get into what modifiers are, but I just wanted to let you know that that's a little trick you can do. So there you go once again, Regex 101 or Regex RX. Love this program. This is the best. Or for Windows, Regex Buddy. If anybody actually knows any other really good programs or online resources, feel free to let me know, and I can add it for everybody else to have a look at as well. All right, moving on to the next one. Let's begin. All right, so let's dive right in with literal matches. Now, literal matches are exactly as they sound. It's something that matches literally. So, for example, I'm going to type in cat, and this is the search pattern, and this is the source text. So this is what I'm searching for, and this is what I'm searching against. And as you can see, cat finds cat. It's a literal match. There we go. Not too difficult. For just to add another thing, cat dog won't match because I'm literally looking for cat space dog. If I type in dog, there we go. If I add another cat, it'll still match the cat dog, but it won't match the cat because, of course, I'm looking for cat dog. That's a literal match. One more thing that I'll add just to show you how it works. Say, for example, I have the text 222, okay? If I type in 22, as you can see, it matches the first twos. Now, the reason why it's not matching this leftover 2, see this 2 right here, is because the 2 has already matched. Think of it as being consumed. So if I added another 2, so now we've got 2 different matches, 2, 2, 2, 2. This here is not matching. That's because this already matched. So it's searching from left to right. So it found the 2 2s, it was a match. It found another 2 2s, it was a match. If there's a single 2, won't work. So I just wanted to point that out. And that's it for literal matches. All right, so up next we have character classes. Now things are getting a little more interesting. Basically, character classes try to match individual characters within square brackets. So to demonstrate, there's the square brackets, and let's do all the vowels. So A, E, I, O, U, sometimes Y, and there we go. So as you can see, all the vowels are now being matched individually. Pretty cool. To make it a little more interesting, you can also do ranges. So instead of typing out all the characters, like A, B, C, D, E, F, G, all that, you can do a range of characters. Say I want to match A to Z, for example. So it's A-Z. There we go. All the characters have been matched. This is also case sensitive. So if I added A, B, C, D, E, F, G, for example, that's not going to match. But if I type in a capital A, we got the capital A, we got the B, we got the C, so it matched. We also can put this in a range. We can do Z as well, and it'll get everything. So now we've got 2 different ranges. It doesn't matter the order. We can put this over here. Same idea. We could change the text. We can put it over here. It doesn't matter. It's looking for each individual character. I could put a whole bunch of capital characters right there. They're all matched. No problem at all. So character classes, you can intermix the ranges and the individual characters themselves. And you can even put in like digits. So if I have a bunch of digits, currently they're not matching. I put in, look, I can put a 1, I can put a 2. The 1 and the 2 have been matched. You can also do ranges. I can go 1 to 9, for example, right? And now there's no need to put the 2 because this is represented here. So there we go. All the different uppercase, lowercase, and digits are now represented within this match. Pretty neat. Another thing you can do is you can negate matches. So a negation is whatever it's not. So for example, say I want everything matched that's not the lowercase a to z. Currently right now it's matching only the lowercase a to z, but by doing the negation, I can add in the carré. So now, as you can see, only uppercase and numbers are being matched on the screen because those are things that aren't lowercase letters. No problem. Now, one thing to take note of here is that regex gets confusing because these special, like this carré has this special negation feature within a character class. If you put a carré in the front of the match outside of the character class, it has a totally different meaning. And as you can see, only the capital A was selected. What's going on? I'll get into that in a later video. I just wanted you to be aware of, just in this context, this carré means negation. And this is going to be really useful later on when we learn how to use quantifiers, but we're going to get on that in a different video. But for now, just know that a character class match, as it is right like this, matches individual characters. Oh, another good thing to notice is that the dash, what if you actually wanted to match a dash, right? Because you can't put in a dash because it means something special, right? There's 2 ways of doing it. I can do a backslash dash, which makes it a literal dash. It takes away its special meaning. You're going to see these backslashes used for different things later on, but for now, just know if you want a literal dash, you can do a backslash dash as I did. Or there's another way. If you use a dash as the last character in a character class, it just means a dash as well. So you either can put the backslash, which means escaping. That's what they call it. You escape the special meaning of the dash. Or you can put the dash at the end of the character class, and it means it's a literal dash. So hopefully that made sense. but that's how it works. So let's see. So I did negation. I did the backslash dash. I think that's it for now for character classes. So that's character classes, and we're going to be using them. Right now they don't seem that useful because of the matching the individual characters. But as I said in subsequent videos, we will see the power that these things have. So stay tuned. So there was one more thing I wanted to clarify with character classes, and that's you don't have to just match letters or numbers. You can match any character. So I'm just going to type a bunch of characters. I'm not going to put it there. I'm going to put it in the source text. And then with a character class, for example, I can do something like this, right? So if I put a caret in, if you'll notice that the caret is matching, right? Only remember, this caret has special meaning at the beginning. So if I put it there, it's a negation, okay? But you can match against anything. And another neat trick, I'm going to do this against the ASCII table. There's all kinds of stuff you can do with Unicode characters, but I'm not going to get into that in this beginner class. But we're just going to load up the good old ASCII table, and I'm going to pick a range that starts at the space and ends at the tilde. So what that should do is it should select everything from space to tilde. So it should select all those different characters that I put in the screen, as well as any sort of letters and numbers. So let's verify that. It's just a neat little trick. So if I go space, range to tilde, everything gets selected. And if I put in lowercase letters, uppercase letters, numbers, everything is selected. So I just wanted to make it point that out, that you're not just matching against the letters, numbers. You're matching against any character. And that's it. Okay, so up next we have alterations. Alterations are pretty fun. Let's do some source text. So I'm going to do cat, dog, and fish. Okay? It's probably easier just to show you. So I'm going to type in cat, a pipe, and a dog. So this is the alteration right here. So what's going on? As you can see, cat and dog got selected. So what an alteration does, it tries to match what's on the left of that pipe, and then if it fails, it tries to match the next alternative, which is dog in this case. Okay? So going through it, it gets to cat, right? It says, does cat match? Okay, good. Next up, does cat match? No. Does dog match? Yep. Okay, that's good. Does cat or dog match? Nope, doesn't work. And alteration, you can keep chaining them as much as you want, right? So you can do all kinds of things. So now it'll find either cat, dog, fish, or bird, and so on. And that's alteration. Okay, so up next is meta characters. Now, meta characters are interesting because some of them require backslashes in front of them to give them special meaning, while other meta characters require a backslash to give it the literal meaning. That sounds so confusing. So let's just give some examples and show you what I'm talking about. So let's type in the meta character of the dot or the period. So what does this mean? So if I type in the source text a period, it matches. But if I type in anything else, it matches as well. What's going on? This meta character represents anything except for new lines. So the only thing it doesn't match is new lines. If you wanted to match against a literal period and that's it, you would have to escape it, and there you go. You get the literal period right there. So just so you know, that's a meta character. It's probably one of the most misused meta characters, and we'll see why later. It's a little dangerous sometimes if you well, not dangerous, but you can match things that you may not intend to match, and we'll show that. I'll show that a little later. But here's some other meta characters for you. So meta characters as well, they're like shortcuts for certain character classes. So remember the character class A to Z, 0 to 9. Whoops, 0 to 9. We did that one before. So if I add an underscore to it, okay, now all that's quite a bit of stuff. You save a lot of space by doing those dashes, giving them ranges, but it's still a lot of typing. And there's a shortcut for it. The shortcut is simply this, \W. The exact same match comes up. So that is a meta character, so it matches exactly what we had on the screen there. All of that is represented in this special meta character. Saves you a lot of typing, and that's a very useful one. If you wanted to do the negation, so remember how to do negation, the carré. If you wanted to represent that, all you have to do is do \W, and it's the same thing. If you wanted to do all the digits, remember the digits looks like this. Let's see here. Let me just get my thing going. There we go. Right? If you want to get all the digits, the shortcut for that is just \D. Pretty cool. And of course, the negation again, and the negation will look like this, right? All you have to do is \D. Not too bad. Now, if you wanted to match tabs, I can't represent it in this program, but it's \T for tabs. If you wanted to do new lines, or line breaks, it's \N, and you can just hit enter, and as you can see, that's the match. It kind of puts a long line across the screen, but that's a new line match. If you wanted to match any kind of space, whether it be tab or line break, you can just, let's add a few here. Before I do anything, let's put back that enter. So it's \S. So as you can see, all kinds of matches going on there. If you want to do the reverse, so anything that's not a space, not a tab, not a line break, not a new line, you can do \S. So it's just selected all the characters. If you want to do just a space, you can do \space. I like to do this because there's some situations where it's just a good idea, in my opinion. You can just type a space, same thing, but you'll see why later. I just, for myself, just to be safe, I always \, and then put a space. So I'm just escaping the space, so it's definitely a space. And once I talk about modes, you'll see why I do that, but you don't have to do that in this context. Yeah, so, and also, let's see what else there is. Oh yeah, you've seen that there's some characters that have like special meaning, like character classes, right? So what if I wanted to match the actual bracket? So same idea. You escape, or you just put \s in front of them, and then now you have literal square brackets. And that's it for now for meta characters. There's a whole bunch of other meta characters, but I'm just going to stick to that for this introduction. And it's quite a bit. I understand that. And there's all kinds of different things and different contexts, and it can be confusing. But with practice, and once you get it, it gets really awesome and very powerful. And we're going to see in the next video where things are going to get pretty amazing with quantifiers. And that's going to make all these things I've been showing you incredibly useful. So I'll see you in the next video. It's time for quantifiers. Things are going to get interesting because so far we've only seen literal matches and individual character matches. But Regex has the ability to match multiple things at once, and that's accomplished via quantifiers. The two quantifiers I'm going to introduce are the star quantifier, which means 0 or more times, and the plus quantifier, which means 1 or more times. So how do these things apply? Okay, let's do a sentence. Hello, how are you? Okay? And what I want to do, instead of matching the individual characters, I want to match the words themselves. So how is that accomplished? Well, with quantifiers. So let's start writing this. I'm going to use a character class, A to Z, and as you can see, all the different characters have been highlighted, But as I said, I want the words, so let's add one of those quantifiers. I'll add the plus. And as you can see now, all the different words have been selected. So what it's doing is anything from A to Z, one or more times. And the other one works exactly the same in this situation, or it matches the same. It's not working the same because what it's doing is it's going A or Z 0 or more times. It's a subtle difference, and I'll show you later to illustrate exactly what that difference is. But just for right now, there we go. We're matching chunks as opposed to individual characters. We also can do this against numbers. So let's just do a whole bunch of numbers and say I want to match against all the different sequences of digits. So I want these three things matched. So I can do the same idea, right? Another character class. I can do that, and all three sequences are matched, or I can use the star, right? And there we go. Oh, it's not just with character classes. You can use meta characters as well. So the D meta character is the same idea, 0 to 9. And as you can see, everything is matched individually, but we want that quantifier goodness here. And there we go, same effect. So yeah, quantifiers, highly useful. Now, one thing to keep track of with quantifiers is that they're considered greedy by default. What does this mean? This means they try to consume as much as possible. Now, the best way to explain this is by example. So let's do something with p tags. So this is an HTML thing. Let me write a bunch of p tags. Paragraph 1. And let's do paragraph 2, paragraph 3. And say what I want to do is I want to create a regex that matches each individual paragraph start and end tag, okay, and everything in between as well. So that's what I want to make. So how do we do that? So we know that everything starts with a P, right? All these three different tags start with that opening P tag, and it has a closing P tag like this as well. And there's a bunch of stuff in between. So how do we represent that stuff in between? We could try to do a character class and guess what characters are there, or we could use that meta character that introduced in a previous video, that dot, match anything but a new line meta character. Now we can give it a star, for example, and that will say match anything 0 or more times. Let's see what happens. Ooh, not exactly what we were looking for. Now what's going on here? Because we wanted to match, right, from the opening paragraph tag here to a closing paragraph tag. So we wanted to match this, not the whole thing. Well, this is because by default, as I said, it's greedy by nature, okay? They're trying to consume as much as possible. It's saying start here, grab everything all the way to the last occurrence that we can find of this closing P tag. So it's actually consuming right over all these other, right, closing P tags. We don't want that. Well, maybe sometimes we do, but not in this particular situation. This is where using this this like wild card match anything thing can get you sometimes a match that you're not necessarily wanting. So what we have to do here is we have to modify this quantifier with yet another quantifier, the question mark. And the question mark is used to make something non-greedy. And when you do that, as you can see, we now have each individual opening and closing paragraph tag has been matched. So what's happening here is that it's matching the least number of possible results versus the most, if that makes any sense. So yeah, this is the non-greedy versus the greedy match, okay? So that's what I wanted to say about quantifiers. Oh, one more thing. You could use this question mark by itself, okay? And let me just do something different here. Let's say we have a website, okay? Website.com, and we got website2.com. So we could write something like, okay, let's match that. So it's matching the first one. It's not matching the second one because there's that HTTPS, right? This is the HTTP part, and match anything after that. So we could do something like, you could do something like that, an alteration. It's not a wrong answer, but let's do something a little more fun by adding the S and then adding the question mark by itself, okay? So what it's doing, it's making an individual character that comes before it optional, okay? So now we're getting both the matches. If you wanted to do a literal question mark, because this is once again a special kind of character, you'd have to add, remember, the whole backslash, which is called escaping. But there's no question mark. If we had like a question mark here, it would have to actually be a question mark. There, that would match, right? But okay, so that is quantifiers. And as you can see, highly useful. We're starting to now be able to write some pretty cool things, and it's going to get more and more interesting, more and more complicated, complex, but way more fun. The next topic we're going to do is iteration, so I'll see you in the next video, and yeah. So up next is iteration. And iteration is just like quantifiers, but it matches a particular amount of times, okay? So in this example, let's say we want to match 4 fours. We could use the tools we've already learned, for and the plus quantifier, which means for 1 or more times. We can use the star for 0 or more times, right? We could literally type out 4 fours. That also works. We could even use the dots here. Seems to work. However, if there was something like this below it, now we're matching something we don't want to match. So let's do this with iteration. And iteration uses the curly brace. So how you'd match the first line there, that 4 fours, is like that. So match 4 times. Pretty straightforward. If you wanted to match a range, you could do, for example, say I wanted to match 2 to 4 times. It uses the comma here, so this is the range. Now you'll notice that it seems to be greedy because it's matching 4 times by default. If we added the question mark quantifier, all of a sudden we're defaulting now to non-greedy, so we're matching the sets of 2 before the 4. So we've got 2 different matches here. 4 is one match and 4 is another match, right? So say we add 2 more 4s. We've got 3 matches. If I remove the non-greedy quantifier, now it's defaulting to greedy, so it's going to grab 4 times, and then but for the next match, it'll grab it 2 times. So hopefully that makes sense. That's pretty much iteration. It also works with, let's do this. Hello, for example. It can be a character class. It could be for like character class. It grabs, see, that's a character class. That's a quantifier. Iteration. We could do something like, how many letters are there, right? It selects it 5 times. If it was 6, it wouldn't work because this is only a 5-letter word, right? If it's below it, 3, it'll grab the first 3, right? There's one way you could create a range that's infinite. So we can do something like, say, grab 1 or infinite times. So you're grabbing 1 character that's within this range, right? This meta character range. And once again, that range looks like this: A to Z, A to Z, 0 to 9, and underscore. So it's pretty much, this is equivalent to this, right? So we can do 0, right? This is equivalent to this. Pretty cool. But say we wanted to grab, I don't know, only 2 characters for some reason. There we go, 2 characters. So it's grabbing these 2 and these 2. We could do grab 1 or 2 characters. So it defaults to greedy, grabs the 2, then grabs the remaining 1. And that's pretty much iteration. Iteration does come in handy in certain situations, and at the end of the course I'm going to have like some examples, and I will use iteration to show you some instances where it can be very useful. So let's move on to the next video. We're going to be tackling capture groups and non-capture groups. Up next, we have capture groups and non-capture groups. So what is that? Let us give an example. This is a very simple literal match, right? Now a capture group grabs a segment and saves it to memory, and also has the added effect of assigning a variable to it. That variable starts at 1 and increments to 9. All I'm saying here is that right now it's captured this text and saved it to a variable, and that variable is number 1. I can back reference, invoke the contents of that variable in the context of this regex by just simply doing \1. So all I'm really saying is that it just did this, right? So far, so good. But it's written like that. Where this comes in useful is when we start doing things in programs, and you're going to be able to pick out different segments and then manipulate them. You even can do a find and replace kind of thing with regex, which I'm not going to get into. I might in the examples, but I'm not going to get into it right now. There's a few more things I want to show. Let's see. As well as the quantifiers and iteration, you can do it against these capture groups. So, right, it's just repeating cat, cat, cat. It's repeating this segment over and over again, okay? And also this one works, right? We got this works as well, an iteration works, so it's pretty cool. What I'll do is I'll give you an example now of how we can target something specifically. In this example, let's say I have a list here of URLs, and all I want is I want the domains. I don't want the paths. I don't really care about this over here. I just want the domains. So using what we've learned so far about capture groups, I can write something like this. I'm going to put the S in, and I'm going to make it optional because there's one of them that has that HTTPS, right? And to match just the domain now, I could do something like this. I'm going to negate the / because domains aren't allowed to have /, right? Put a plus, and I've got everything I want. Now, I don't want this HTTP, and there's a better way of doing this, and I'm going to show you that in the next video. But for now, let's just do this. We put it in a capture group. Now, if I was in a programming language, I could take the contents of this variable and use it and discard the rest. I'm going to show you examples in different programming languages later on, but for now, just know that that is one way to carve out segments that you want to match, and you can manipulate them. So that's coming later. Okay, let's do non-capture groups. Non-capture groups is the same idea as a capture group pretty much, but it doesn't capture it to memory. And let's see here. So if I go hello, hello, right? I'll do something like this, hello, right? So it's created a grouping, a segment, but there is no, like if I did this, it doesn't do anything because there's no variable being saved with the contents of hello. So what you can use this for is if you wanted to have, like, as I said, you only have 9 capture groups, but it's still highly useful to be able to, like, watch this. I can do like this. I can leave a space, right? And it's still useful to do things like that. Like I have this grouped segment that I can throw quantifiers against. It's just the syntax. You have to remember that you have to put this $:" in front of it, and that gives it this special non-capture group meaning. There's so much more to talk about with capture groups, but that's where I'm going to leave it for now. Once again, later on, I'm going to give all kinds of examples, and hopefully that will shed some more light on how they're used in the context of programming. But we're going to go on to the last topic, and that's called lookarounds. This is going to get interesting. And hopefully not that confusing, but I'll see you in the next video. Okay, so it's time for lookarounds. Now, there's 2 different types of lookarounds. There's look-aheads and look-behinds, okay? And each one, so a look-ahead has a positive and a negative version. And these are called zero-width assertions. This means that they affect the outcome of the match, but they're not included in the result. Now, I'm going to show you some examples to make sense of all that. So here we go. So for example, here's some sample text. Silly cat, happy cat, cool dog, cool bird, cool fish, fun cat. And for this example, say I want to match the word cool, but only if there's a space and cat in front. And we're going to use a positive look ahead. So type the word in cool, all the cools get selected. Now for the look ahead. So we're starting it off like this. This, as you saw in the previous video, is a capture group by default if you leave it like that. But you also saw I made it a non-capture group by doing that. In this case, if you do this, it becomes a positive look ahead. It's not a capture group. Nothing's being saved to memory. It's a positive look ahead. And what you do after this is you type in what you're looking for. So it finds the word cool, and then it peers ahead, and it says, hey, does this exist? Does this exist? Does this cat exist? Yep. Therefore, it's a match. So that's a positive look ahead. A negative look ahead, all you have to do is give it an exclamation. So now it's saying cool, look ahead. If there's a space in a cat, don't match it. So all these cools got matched. So that's the positive look ahead and the negative look ahead. So now it's time for the look behinds. There's a positive and a negative look behind. So in this scenario, I want to select the word cat, but only if the word cool and a space is before it, okay? So same idea, question mark, but this time it's an open angled bracket, equal sign, and then cool and a space, right? So it's just, look at this, here it is, look behind, so go back, look behind, right? And does this exist? Yep, therefore match. So there we go. And the negation of this is just like that. So now it's selecting everything that has the word cat that doesn't have a cool and a space before it. And that's pretty much lookarounds. One thing to remember about lookarounds as well is that when we start doing the look behinds like I was doing here, right? These are usually, depending on the engine, but for the most part, fixed width. Okay? That means that this has to be the exact amount of characters. You can't put quantifiers. If I tried to put a quantifier, an error will come up saying invalid expression. Look behind assertion is not fixed width. So just to be safe and to write a regular expression that's universal, always remember that this is fixed width. That doesn't count for the positive. Positive can be as, you can use quantifiers or anything you want. So if I just did cool, and I said that something had to be in front of it, right? There has to be something in front of it. See, it works. But the other way, it has to be a fixed width. So next up we have modifiers, and then after that we're going to take all these rules, all these tools, all these skills, and we're going to start applying it to practical examples. So stay tuned and check it out. I've got another zero width assertion for you. It's not a look around, it's a boundary, and it's a meta character, and it's invoked by doing this. I don't really use it very often, but it might come in handy to you. What it's supposed to do is that it tries to match instances where a word character transitions to a non-word. So what does that mean? So if I go something like, say I go, woo, right? And say I had something like this, woohoo, or I had woohoo, like that, right? So I just want to match the word woo only if it's by itself, not in the context of this right here, right? So I could add this meta character and it only matches that. So as you can see, it tries to match instances, as I said, where a word character transitions to a non-word. I just thought I'd show you that because it could be useful in certain situations, and there you go. Okay, now let's do anchors. So anchors are things that match the start or the end of a string. And the two special characters that do that are the caret. We've seen this before, but this is going to be used in a different context. It means something totally different when it's not in a character class. This means the start of a string. And there's also the $, which means the end of the string. So if we have a sentence here, right, and I want to match the first this in this sentence. I'm matching both. I don't want that. I just want the first one. Put a caret, and you got it. We also could do something like, I want to match any word character. Still the same thing, but this word can be anything. Right? This is the anchor. It's anchored right here, and match any word character one or more times, and that's what it's doing. If we wanted to do something like that for the end, say I wanted to match the last word character, including periods, why not? We can do something like, let's do, well, we can do it like this. And we can give it a quantifier, and there you go. So this just anchors it at the start or the end of the string. You can modify how the anchors work, and that's going to be shown in the next video, which is called modifiers. So see you there. All right, we made it to modifiers. This is going to be the last concept before I break into some practical application of regex and all kinds of examples. So let's do it. Modifiers. So modifiers change the behavior of the regex pattern, and there's two methods to invoke them. There's the inline method and the end of pattern method. And the end of pattern method really relies on the programming language or application. So I'm going to just focus on the inline method. And the modifiers I'm going to show you are the M, the I, the S, and the X. So there we go. Those are the modifiers. And what do they mean? Let's do one at a time. So the first modifier is going to be the M. Okay, and it's related to the last video on anchors. This is some text. This is la 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 la. Text. Okay, so we saw in the last video, if we used an anchor, that what happens is it selects only, right? It's anchored here at the beginning of the string. But say I wanted to capture the beginning of every line of the string. Okay? So what we can do is we can use this modifier, the M, and now that is accomplished. And it also works with the anchor for the end of the string as well. So let's do that to show you as well. So I'm going to do something like this. I'm going to do that. It's capturing those, right? If I get rid of it, it's only going to capture this. Great. That's the first modifier. So that's the M modifier. The next one I'm going to do, I'll do the case insensitive one. So there's a case insensitive modifier. Question mark I is how it's invoked. And what this does, if I had like a character class and I did something like this, it will still match the capitals. Case insensitive. Cool. So another one changes how the new lines work in the dot meta character. So if you remember what this does, match me and match me. It matches anything, any character that is not a new line, one or more times with this quantifier. But if I put in the S, it'll also now match against new lines and grab everything. So be very careful when you use that modifier and the dot wildcard, because you get this results. Another one, my personal favorite, and the final modifier I'm going to show you, is the X modifier, which is the free space mode with comments enabled. So this one makes the regex pretty readable. There are some people that say that regexes are hard to maintain because they're difficult to read, understand. It is very hieroglyphic, all kinds of different characters, meta characters, character classes going on. But you can break it down now and you can make it highly readable. That's pretty neat. The only thing to remember in this mode is that you have to escape spaces now. So that's why I got in the habit of escaping my spaces. because I use this mode quite often, and we're going to see in the examples I'm going to do, I'm going to use this all the time, and they're going to be highly readable, highly maintainable. You're going to love it. So there's the modifiers. Oh, you saw in the beginning of the video, I didn't explain it, but you could use all the modifiers you want together. And it doesn't matter the order. You can invoke them all at once if you wanted to. If you want to do each one that I showed you, no problem. And you could do something like this. So let's turn it on. Let's go the first word. We're going to match, no, let's do this. We're going to match something like this. Let's do match me, okay? And let's do this, anchor it. So match me. And then this is matching because it's lowercase, but this modifier is saying it doesn't matter, case insensitive, right? And if I did something like, let's do it again. Let's do something like that. But I want to turn off the modifier. You can do that as well. So this is not matching anymore because it's matching for this part because the case insensitive is on, but then I turned off case insensitivity and it doesn't match for this. So we'd have to do something like this. So the inline modifiers are cool because you can activate and deactivate them anytime you want. And that's modifiers. So I think without further ado, we're going to get into some practical examples. One more thing I'd like to say is now throughout this whole tutorial, I've showed you only a glimpse of some of the really cool tools and concepts of regex. If you went into this program, for example, you'll notice that there are so many more different things you can do with regex. And since this was a beginning course about concepts, I just wanted to stick with things that would get you going right away. But you can totally like dive right in and you can do all kinds of awesome things. Maybe in the future what I'll do is I'll do a more advanced course and I'll talk about all kinds of these things like what's being shown on the screen right now. But for now I think we have enough to get going and to write some pretty awesome regexes. So without further ado, let's do some examples. All right, so in this next section, I'm going to be giving you a whole bunch of different examples. If there's actually something you'd like to see, feel free to contact me and let me know. But I'm just going to randomly be selecting interesting things and then throwing regexes against them. I'm also going to try to put the regexes into some programming languages so you can see their application of how they're going to be used. I won't be able to explain every single detail of the programming language part, but at least you'll get an idea of how they're being used. And throughout time, I'm going to be adding more and more examples. So without further ado, let's begin. Okay, so in this example, I'm going to match some phone numbers. And these phone numbers you see here, these are phone numbers that you'd find in the United States or Canada. One thing I want to say about creating patterns for things like this, or for anything really, is that don't think of these example solutions as the be-it to end-all solution. Regex are pretty fluid. You have to react to the data you're given. So there's no real one-size-fits-all regex pattern. Okay, with that said, let's begin. This is tricky because there's all kinds of different things that are interesting how it's starting. It seems like the pattern here, this stuff is pretty common. This is unique. This is very unique. It looks like an international code, somebody calling this number internationally. That's my guess. But let's write something. So let's deal with this first because this is the most unique example or the most unique occurrence of these characters. So let's see. What I'm going to do is I'm going to anchor it. Oh, first of all, let's put on some modes. This is multi-line mode and free space mode. So I can do something like that. I'm going to anchor it at the start, and we're going to say, let's get this off the screen, we're going to say, let's do a non-capture group. And there's a reason I'm going to do that. I'm going to show you in a second. So it starts with a plus, so we have to escape the plus because that has special meaning. It's a quantifier. And it has digits, and I believe it could be either 1 or 2 for this kind of code. Okay, not so bad so far. And then, let's see here. there's a space afterwards, and this is optional. So if you remember, that's the question mark quantifier. Okay, pretty good so far. Now we have this stuff, these parentheses here and here. So let's deal with that next. So the great part about free space mode is I can make a new line, make it a little more readable, right? Deal with it in chunks. So I have to deal with this parentheses. It's a literal parentheses, and parentheses have special meaning again. So we have to escape it. And then there's a digit, and that digit seems to occur 3 times. And then there's another parentheses. But these are only optional, aren't they? So if I do something like this, now, excellent. Everything got selected. Now it looks like what's coming next is there's different occurrences. It could be dots, it could be spaces, it could be dashes. So let's create a character class. And in this character class, I'm going to do a space, I'm going to do a period, and I'm going to do a dash. Okay? So we're going to do that. And it only happens once, so I don't need to put a quantifier against it. And then there's digits. So there's 3 digits. No problem. We've got the meta character D right here, right? And we have the iterator of 3 because it happens 3 times. And it seems to be working so far. This seems to repeat itself right here because, again, we're dealing with dashes, spaces, or periods. And then there's simply another digit 4 times. Wow, there you go. So we've managed to fulfill all these scenarios perfectly. So there's our regex. Let's have a look what it looks like if we were to write this out in one line. Yeah, see, this is why regex gets a bad rap, because if you saw that, that's very hard to decipher, even by me just looking at it. You'd really have to think about it. So breaking it down into components really helps, really aids with seeing all the little chunks and how they work. And that's pretty much how you have to deal with a regex like this. Just deal with one thing at a time and build it up with all the rules you learned. And then as soon as you know it, you got the solution. All right, that's it. All right, so for this example, we have a CSV file, and that stands for comma separated value file. And all we want to do is we want to grab the data, the good stuff. We don't want these commas. So the commas are the delimiters. So how do we write a regex for that? I think a character class looks pretty good for this, and we can just say anything that's not a comma 1 or more times. Oh, look at this. These represent new lines. So we can just add in anything that's not a new line as well. And that's it. Now, CSV files may not be this simple, but this gives you a basic idea of how to solve this problem. And that's it. All right, so in this example, we're going to craft a regex that selects this information and this information in this test data below. Where did I get all this from? So I'm using a Mac, and I'm in the command line right now. And there's a command called ls, and I'm giving it the parameters LA. And what this is simply doing, it's just showing all the directories and files in this folder, and this represents the permissions, and this represents the name of the file and or directory, okay? So that's where the test data came from. And all I want in this case is I want this, and I want this. This, and this, okay? So how do I select that information? Well, let's do an anchor, right? Oh, let's give it the M modifier first. And let's do X as well, so we can do some free space mode. And the M, once again, changes the way the anchors work. So instead of the start and the end of the string, it's going by each individual line, right? And let's give that anchor, the start anchor. And we'll say anything that is not a space, because I don't know what characters are going to be represented, and I don't want to think about it. So I'm just going to say anything that's not a space one or more times. And that got selected. And let's do our alteration. And let's say, again, anything that's not a space all the way to the end. And there we go. So what you'll notice in this top line, it's a bit different, but it is following the same rules. It's the first and the last column being selected. See that? This is the first, this is the last, that's the first, that's the last. Pretty cool. Okay, so in this example, we have some HTML code, and as you can see, it's a table, right? It's got 3 columns and 3 rows, so there's the first name, last name, and age. And then there's the data itself. We want to grab this data. We don't want to grab this, and we don't want to grab the tags. So how do we do that? Let's begin. First off, I'm going to use the modifier-free space mode. It's going to make it a little bit more readable. And let's target everything that is not an angled bracket. So this is a negation. Everything that's not an angled bracket, 1 or more times. Doesn't look highly useful so far, but we're going to use a positive look behind to bring this all together. So something like that, right? And we're going to say TD. So what happened? Look at that. It worked. What's going on? Target everything here. As I said, negation. Everything that's not an angled bracket 1 or more times, but this has to be true as well. So look behind, and if there's a TD, then match. And there we go. A pretty easy solution. So what I'm going to do in the next video is I'm going to give an example of how we can plug this in to a programming language. And yeah, so stay tuned for that. Okay, so as you saw in the last video, I was able to target all the first name, last name, and age information within the HTML. In this video, I just wanted to give an example of how to implement this in a programming language. If you don't know the programming language I'm using now, it's Ruby. And if you don't know Ruby, don't worry. I'm not really going to explain everything because there's just not enough time, but I did want to show you just an idea, an example of how you can implement regex within programming languages. Here we go. So there's this end keyword, and that just means anything below it is not going to be run as code. Very useful if you wanted to put like database style information. You can have it at the end of your code. Perl does this as well. And there's this really handy global variable called data. Ruby is an object-oriented language, so everything is an object. Well, pretty much everything's an object. I'm just going to say that. So there's a method called read, and what that does is it reads all of this at once, okay? And then I'm going to scan. So scan implements a regex, and I got to get a delimiter going on here for the regex. That's one way of writing it. You can write it like this as well, but I like hieroglyphics, so I'm going to do this, actually like that. And then I'm just going to grab that regex. It's in my clipboard, and there we go. Okay. And then I'm going to pass a block, and that's a real Ruby thing. So we're going to do actually, we'll do it like this. There's 2 ways of writing blocks. We're going to do it like that. And then, oh, we got to give it one of these, match. And then I'm going to go print match. Actually, let's do puts. Puts leaves new lines. So there we go. So running the program, as you can see here, all the data has been represented. And then you can start doing things with it. You can put it into a hash. You can put it into an array. You could, whatever you want. But anyway, right here, I just wanted to give a brief example of implementing a regex within the context of a programming language. If you have any questions, feel free to ask me. But that's it for now.